So what do I want to calculate? So for part A, I want to calculate the C equivalent. So I want to calculate the equivalent capacitance for all of this system. So I want to reduce C1, C2, C3, and C4. I just want to reduce everything with one capacitor. And then for part B, so for part B, we're going to calculate the energy So I want to calculate the energy stored in the equivalent capacitor. And then finally for part C, we're going to calculate the energy in each So we'll calculate the energy in each capacitor. All right, so let's look at part A. Now, so do you see that? So C1 and C2 is in series, right? So it means that I can combine C1 and C2. So if you combine so let's start by looking at these two here. So let's combine C1 and C2. What do we get? So let's say 1 over C series is equals to 1 over, now C1 is 4, so 1 over 4 plus C2 is 6, so 1 over 6. So solving this equation, what do you get for C series? Let's plug it in the calculator here. Twelve over 5.
You should probably check it out.
What did you say it was?
12 over
12 over 5?
Mm-hmm.
Okay, so 12. You can write this as 2.4. Everyone agrees with that? Okay. So now that we've calculated CS, we can take CS together with C3, right? Now CS and C3, is that a series or a parallel combination? It's parallel, right? So how would you combine those together?
Just add them up.
Just add them up. So now let's calculate C for the parallel combination. We take C3 or CS. So this should just be equals to, so C3 is equals to 2, so this should be 4.4. Okay. Now, we can take C parallel and combine it with C4. Does that make sense? You see that C parallel is in series with C4? right? So it means that I can calculate my 1 over C equivalent. It's 1 over C power. It's 1 over C. Again, solving this equation, you're going to get your C equivalent to be equals to 2.84. And can you guys double check this?
That's what I got.
Okay. 2.84 microfarads. So what I'm saying is that all of these, all of this can be replaced by just one capacitor. So again, the voltage is the same, so this is delta V. And we just replace this by C equivalent. So this is my C equivalent. Now, let's calculate the energy in my C equivalent, right? So my E, so for part B, notice that the energy here. Now I can use any of those equations. So remember that I can calculate energy by doing, so energy is equals to Q squared over 2C, which is also the same as 1 over 2 C times delta V squared. So I could use any of these equations. So since we know, so in this case, I don't know what the total charge is, but I know what the C value, so I can just say that the energy equivalent here, so the energy is 1/2 C equivalent times delta V squared. Now, notice that for me to calculate the energy in joules, I must convert this into farads. So we're going to write this as 2.8 times 10 to the power 6. Now, if you plug in that value here, your delta V is just equals to 12. If you do that correctly, you should get an energy that is equals to 2.04 times 10 to the negative 4.
Why do you not have to square the C equivalent to? C equivalent times delta V is Q, and you have to square all of Q.
Yeah. So now if you start with this equation here, Q squared over 2C. Now in place of Q, you just put, Q is equals to C delta V. So what you're squaring is C delta V squared, right? So the C squared is going to cancel with the C at the bottom. And so you just end up with 1/2 C delta V squared. So everything looks good up to this point, right? So we have our equivalent capacitor, and then we've also calculated what the energy is. So what I'm going to do next is that, so let me just show you what we're going to do next. I want to calculate E1. So what is the energy E1? What is the energy E1 on capacitor number 1? Then I'm also going to calculate what is the energy E2 of capacitor number 2. What is the energy E3 on capacitor number 3? And what is the energy E4 on capacitor number 4? Now, if I can do that correctly, then I can add E1 plus E2 plus E3 plus E4. And what do you think that should give me?
2.04.
It should give you 2.04 times 10 to the negative 4. So that's how you can double check to make sure that your answer is correct. So the total energy in each of the capacitors must be equal to the 2.04 times 10 to the negative 4.